Welcome to the deep dive. Today, we're wrestling with something that feels, incredibly simple. You look up, you see the sun. But what does that action seeing the sun actually mean? It feels so immediate, doesn't it?
It does. It feels like we're getting a live feed, so to speak.
Exactly, like the light just appears right now.
But our sources today, a collection of research on light and time, they suggest that's a profound illusion. The shocking truth is that you are, and I mean constantly, living in the past.
And that's our mission for this deep dive, to unpack that very idea that we're seeing old light. How is that even possible when the sun is right there, directly above us?
So that's the paradox. When you see the sun, the light hitting your eye didn't leave the sun this instant. There's a delay, a very specific delay that physicists call light travel time.
Okay, so let's define that. Light travel time. It's literally the time it takes.
For the photons, yeah. Those little packets of light energy.
Right. The time for them to make the journey from the sun's surface all the way here across that empty space to our eyes.
Precisely. And while I think a lot of people have this vague idea that it takes some time, the actual number is what really forces you to grasp the scale we're talking about.
And what is that number?
Our sources confirm it's 8 minutes and 20 seconds.
8 minutes and 20 seconds.
Right.
That's not trivial. That's enough time to make a coffee, listen to a couple of songs.
It is. And it means the event you are perceiving, seeing the sunlight, actually began 8 minutes and 20 seconds ago.
So the sun we're seeing right now at this very moment is actually what the sun looked like more than 8 minutes in the past.
Exactly. It is always its past self from our point of view. Always.
That is a really difficult conceptual hurdle. We just assume seeing is believing right now.
And that's where something called the astronomical unit, or AU, becomes really helpful. The sources bring it up to give us some context.
Right, the AU. That's the average distance between us and the sun.
Yes. So when we say light takes 8 minutes and 20 seconds, that's the time it takes to cross one AU. It gives us a kind of yardstick for our solar system.
So if a planet is, say, 5 AUs away.
Its light travel time is 5 times that. Simple as that. It helps you map out the delays.
Okay, so this brings us to the big why. Why the 8-minute gap? I mean, light is supposed to be the fastest thing in the universe.
And it is.
Yeah.
That's what makes this so interesting. The issue isn't that light is slow. Not at all. The issue is that the distance is just, well, it's gargantuan.
Let's just state the speed, because the contrast is what's so wild. Our sources give the number as 300,000 kilometers
So second,
per second. That number just doesn't compute in a human brain.
it really doesn't. Light can circle the Earth 7.5 times in 1 second. It's the absolute cosmic speed limit. Nothing is faster.
So if it's moving that fast, why isn't the delay like a millisecond? Why 8 minutes and 20 seconds?
It's the scale challenge. We're talking about a distance of about 150 million kilometers.
150 million.
Yeah, and even at that unbelievable speed, covering that much ground just takes time. It takes 500 seconds, which is,
8 minutes and 20 seconds.
there you go.
So the delay isn't a story about light being slow. It's a story about how incredibly mind-bogglingly vast spaces, even in our own backyard.
It forces you to respect that gap. And this is just to our sun. If we look a little farther out, say, Jupiter. Okay. Which is what, about 5 AUs away?
Roughly, yeah. Around 5.2 AUs. So the time delay jumps dramatically.
So we're talking 5 times 8 minutes.
Yeah.
More than 40 minutes.
40 to 50 minutes, depending on where we are in our orbit. So when you look at Jupiter through a telescope, you are seeing a planet as it existed almost an hour ago.
And that's still just within our local neighborhood.
Wow. Okay, let's bring this back to the sun, because the sources talk about a really terrifying implication of this, the hypothetical disaster.
This is where it becomes very real. We've established we live on delayed light, right?
Right.
So what happens if the source of that light just stops?
The sources pose the question, if the sun were to suddenly be extinguished, like a light bulb switching off, what would we experience?
For 8 minutes and 20 seconds.
Yeah.
Nothing.
Nothing at all.
We would have no idea. We'd be living in this bubble of normalcy, a terrifying normalcy. The last photons from the sun would still be on their way.
So the sky would be bright, would feel the warmth,
That's
all
right.
based on energy from a star that, in this scenario, is already gone.
It's already dead. It highlights that fundamental disconnect.
Yeah.
Our reality is tied to the sun's recent history, not its present.
Only after that final photon completes its 150 million kilometer journey,
Would the sky suddenly go black? The light would just cease.
that delay is built into the fabric of the universe. And it's not just light. Our sources point out that gravity works the same way.
That's right. The sun's gravitational pull also travels at the speed of light.
So if the sun vanished, we'd continue to orbit its ghost for 8 minutes and 20 seconds.
And then the Earth would, well, it would fly off into space. Both signals, the light and the gravity, arrive at the same delayed time.
It reinforces that universal speed limit. No information gets here faster than light. We are always fundamentally seeing and feeling the past.
And that's just our sun.
Now we need to zoom out, because this isn't just a local solar system quirk, it's a universal truth.
Exactly. When we expand the scope, the time lag stops being measured in minutes. It becomes years, centuries, millennia.
The nearest star to us after the sun is Proxima Centauri. How far is that?
It's over 4 light years away.
4 light years, so the light we see from it tonight.
Left that star 4 years ago. You are seeing Proxima Centauri as it was back in 2021.
Wow.
This is where the whole concept of old light really hits home. Let's take an even bigger example. Betelgeuse.
The big red star in Orion's shoulder.
The very one. A massive red supergiant. It's about, give or take, 500 to 600 light years from us.
600. So the light that's reaching my eyes from Betelgeuse tonight left that star around the year 1425.
Precisely. It's been traveling through space for 6 centuries. Now, here's the kicker. Betelgeuse is expected to go supernova, to explode.
Right. Any day now, in cosmic terms.
Well, it could have already happened. It could have exploded 100 years ago. Could have exploded last Tuesday.
And we would have no idea.
None. We'd keep seeing it shining up there, night after night, for the next several hundred years. We'd be looking at a ghost.
A star that's already gone, but its light is still arriving.
Until that final photon from the explosion finally reaches us. This is what the sources conclude. The entire universe is constantly showing us old images of itself, never its current reality.
So when you look up at the night sky, you're not seeing the universe as it is now.
You're looking at a history book.
A cosmic history book. The farther you look, the deeper into the past you see.
Exactly. You see a galaxy that's, say, 10 million light years away. You're seeing it as it was 10 million years ago. Dinosaurs were still roaming the Earth when that light started its journey.
It just completely transforms what seeing is, the sky is. It's a real-time record of the past happening all at once.
It means the universe we can observe is fundamentally different from the one that actually exists right now. We only ever see the echoes. The delay is just part of the physics.
So let's try to tie this all together for the listener. We've covered the key points from our deep dive. The 8 minutes and 20 seconds for sunlight to reach us.
Right, the time to cross 1 astronomical unit.
The incredible speed of light, 300,000 kilometers a second, which, ironically, is what creates this delay over vast distances.
And the universal principle of light travel time. The main takeaway is that your entire view of the cosmos is filtered through time.
The farther you look, the older the view.
The present moment is really just a local phenomenon. Anything distant is, by definition, history.
Which leaves us with a final provocative thought. If every photon hitting your eye from the sun or the most distant galaxy is from the past, if everything you see out there is history, then now is really just the tiny space right around your body. So, for you to consider, if the entire vast, brilliant universe you see is made of events that have already happened, how much of the reality you perceive with your own eyes is truly happening in this very moment?